So, Asif, I didn't realize that on support vectors, you actually have all the YouTube video recordings.
Yes, we
So I
do.
guess it's going to be there for, I was trying to search on your channel and I couldn't find the some of the sessions that you did from last week. So I was scratching my head until you showed it earlier today.
Yes,
So
yes. In
I
the
guess it's
course
going to be
portal
the
there.
norm, right? You're going to have everything here, so we don't need to.
Absolutely.
Okay,
Absolutely.
great.
Absolutely. In fact, from YouTube channel, it will disappear because obviously, if you're paying for it, others shouldn't be getting it free. Um, but on the course portal, you'll have it forever. It will be there.
Awesome.
You can come back
Okay,
1 year later and still review it.
that's great.
And this happens, the way it works is that we'll finish a session by 6 o'clock. By 8, 9 o'clock, my team would have posted it to the course portal, right? And it's always there.
Great.
All
Thank
right,
you.
folks. Yeah. So I just want to do a quick recap of what we did last time. See, and I'll try to be fast because I know for some of you it's a repetition, for some of you it's new. So I'll try to find the middle ground between the two. See, guys, what happens is, how would you like search to be? We are used to doing keyword search. Keyword search, I hope you agree, is the most non intuitive thing. Human beings for 100 million years, they don't talk to each other in keywords. And yet, the last couple of decades has conditioned us to the moment we search, we see a search bar, we start entering keywords. Right? It's time to get rid of keywords. In fact, if you really think about it, how many of you have mostly moved to either Gemini or Chat GPT or Cloud to do most of your searches? Most of us have. And why have you moved there? Because you can ask natural language questions, isn't it? Even though you know that these things sometimes are not up to date with the latest news, nevertheless, you go to them and you treat them as they serve the same purpose that search engines used to serve. Right now, what I'm saying is you can create a modern search interface which truly is natural language. We are going there, right? So here is where we are. What you would like search to ideally behave as is this: you want to give it a search query. But when you give a search query, you give a natural language description, the way, for example, you enter in Cloud or ChatGPT these days. Right? You say, here's a narrative. The user may use a descriptive narrative to explain what she is looking for. This should not be limited to only entering keywords. Yeah, that is the crucial word, guys. Let's get out of the keyword mentality and get back to the way our human brains are wired. Then we want a machine to do magic in between. Quite literally, magic happens, right? This is where AI steps in. And in this lab, we explore some of the simple ways to make this happen. And what do we expect in return? We expect that the documents that match the user's search intent do exist in the search corpus. I mean, they have to exist, they can't magically get produced. They must exist. In this case, we would like the most relevant documents aligned with the user's search intent to show at the top of the results. Right? So this is search. Remember, the one thing that I said is the documents must exist. What if the documents don't exist? Then what do you do? Yeah, there are multiple things. There are two things you can do. And one is you could you may know where it may exist. Like for example, you can search the web for it dynamically. You can search some other sources of information for it. That's one way. The other thing is you have to remember that these large language models, they have been trained on all of human knowledge. So maybe while your documents don't have it, it is there in the parametric memory of the LLM. It is stored in the memory of the LLM. LLM remembers the answer, right? And that is the other aspect. How do we extract it from the parametric memory of the model itself, from the weights and biases of the model itself? So that is the future journey we'll go to. But this, that is the journey that we'll go on in this course. But we'll start with just assuming that you are searching just a corpus of documents, right? But you do expect results to come by. Just to recap what I said, every document or sentence, whenever I remember, a document and a sentence are the same thing in natural language understanding, right? You should not distinguish between them. You have changed location, you, right? Oh, now that you're a team, good, 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 good. Good alliances are forming. Good, right? Yeah. I heard that yesterday one of the independents has thrown in the towel and joined some other camp, right? So in politics, US presidential election. So, yes. So he has changed alliance now. So anyway, in a document becomes a vector in a d-dimensional space. So guys, here's the thing. While this d is very huge, 500 dimensions, 1,000 dimensions, etc., for the sake of your own sanity, it's perfectly okay to do two things. A, always visualize in two dimensions, right? Because it will, you have intuition in two dimensions, right? We can draw things in a page. So always visualize d is equal to 2, you'll be pretty far off. The only thing to remember is the curse of dimensionality. Remember that when you extrapolate from 2 to 1,000, yeah, higher dimensional spaces are strange. They're very strange. Right? They are mysterious things. Everything is far away. There's way too much space out there. It's very sparse. And it also has mysterious qualities. For example, you can't tie your shoelaces in higher dimension. It will unravel immediately. Practical thing, right? I'll let you figure out why. There are no knots. Everything can be unknot in a higher dimension. So higher dimensions are fun, but we'll leave that aside. Now, we talked about this picture. I hope this picture makes sense. Wherever the query lands, look for relevant documents around it. Yeah, these are my notes, by the way. So you have, all of you have access to this. By now you have downloaded this and started this. Good. So now dot product similarity and cosine similarity. There is a little bit of a catch. Why dot? See, dot product and cosine are more or less the same thing. Cosine is normalized vectors. All vectors are normalized to unit size, isn't it? If you use normalized vectors, dot product becomes cosine similarity. What's the difference between using cosine versus dot? See, what happens is when you do dot similarity and you search for documents, you will notice that the search results, the early search results, even amongst relevant ones, it will preferentially favor short documents, right? And when you use dot product, it will preferentially bring forth longer documents. It's an empirical observation. I'll leave it to you to reason through why that could be happening. Right? But it tends to happen. Right? It's one of the things that it does tend to happen. My general recommendation is just go with cosine similarity unless you have a reason to use dot similarity, normalized values. There is also something called symmetric versus asymmetric search. A bit of technicality. Symmetric means the size of your query versus the size of your documents. Right? Generally, if you're searching for things in a Wikipedia, well, your query will be short, your document will, Wikipedia page will be long. If on the other hand, you're dealing with question answer database, right? So for example, you say, what is the capital of India? And the answer should be the capital of India is New Delhi. The question and answer are the same length. In such a situation, you're doing symmetric search. Generally, you're doing asymmetric search. Search is usually asymmetric. Question answer are typically symmetric. You realize that this technology can be used not just for search, but for question answering, isn't it? You create a vector index of only the answers, and now you ask a question, right? And it will pop out the closest answer you can come up with. Do you see this, guys? Isn't it pretty obvious that you can use it for that? And question answering is something you use this for. Now, loading the database. So make sure that the sentence transformer library is installed. If it is not, how do you install a library in Python? Pip install, right? Can I tell you a secret to make it faster? There's a library called UV. So when you do pip install, so first go and install pip install UV. And after that, next time you feel like installing a library, just prefix pip with UV. Just say UV pip install whatever. And it will just install itself 100 times faster. Right? Yeah. UV is one of those beautiful things. I don't know why people don't know about it, but it's very good. So I'll show it to you in action. You pick a model. How do I pick a model? Like I told you, go to the Sentence Bird website, look up the models, or go to Hugging Face, the MTEB leaderboard, pick a good model from the leaderboard, use it. Then instantiate the sentence word. These models are relatively big. Like if you're used to small random forest and decision trees in machine learning, welcome to the world of natural language processing. Everything starts with hundreds of millions or billions, right? Models are like half a gig, many gigs, right? And then there are models that simply won't fit into your machine, like Llama 3.1, a full model. You can't even bring it up on your machine. Most models are so big you can't run on whatever it is that you're looking at in front of you. Right? So this is a new world in which hardware is all of a sudden not enough. What do we do? Let's take some corpus. You realize that what we did is, just to give you a sense of what we did, I just took some, I believe, 16 documents. These documents are very straightforward. One of them is a poem that I like very much, one of my favorites. It's called Jabberwocky. The beauty of this poem is not a single sentence makes sense. And yet, if you read it aloud, it somehow seems to make sense. Right? So, and obviously, it is a good thing because it can really test the power of a natural language understanding machine. Then another one is A Tale of Two Cities. Many of you may be familiar with this famous statement. It was the best of times, it was the worst of times, and so forth. And the last line is, which I find the most interesting, is that the uh, the period was so far like the present period that some of its noisiest authorities insisted on it being received for good or for evil in the superlative degree of comparison only. Charles Dickens was writing about the French Revolution, and the two cities were London and Paris. Is it true more than 100 years later? Is it still true? Every time, today, for example, the big thing is the big revolution is not the French Revolution, it's the AI revolution. Are people calling it the best of times and the worst of times? Right? We seem to be heading towards apocalypse. We seem to be heading towards a world in which we won't have to do the work and machines will do everything for us. So that's that. Um, there are more quotes. The ending of the book is very beautiful. I'll leave it to you. Einstein's quote. So now a couple of quotes about dogs. Mark Twain said, "A dog is a gentleman, and I hope to go to his heaven, not man's." Right? I suppose if you have had a dog, you'll resonate with it. More and more, some quotes. Then Tweedledee and Tweedledum, again from Alice. Keats, "A thing of beauty is a joy forever." And attention, the paper that we are going to study, the abstract of the paper. So I'm taking a variety of subjects, some very technical things, a back propagation, Lucy's Wordsworth poem. Anybody remembers Wordsworth? Right? Or remembers this poem from your, has anybody encountered this poem? It's a, anyway, it's a very touching poem.
Yeah, I was in
Some
high
of them.
school.
In high school, you did encounter. Yeah, this is really nice poems. Anyway, I just threw in some of my favorite ones that I could recollect. Now, this is your corpus. We are going to search with this tiny little corpus and see how far it takes us. We go here. What do? We go and get these sentences, we load these sentences, and then we create embeddings. So if I have 16 sentences, so called documents, how many vectors will I get? 16. I'll get 16 vectors. So what is the shape of this? 16 rows, each vector, how many dimensions is it? 768 dimensions. Should give you an idea how big dimensional spaces these vectors are being projected into. Fear not, I'll tell you a way to visualize it. Now, actually, a lot of it is just gut intuition. You take powers of two or something like that. But 768, uh, every model has a different dimension. So if you go to the MTab leaderboard, you'll see that every guy who creates his own embedding will choose a different dimension. But they all seem to be even numbers. You don't tend to take odd numbers. Creator of the model. So you can pick your own. And you'll see after all you have to do, all you have to do is go look up the name of the model and change it. It automatically downloads. It should be part of the Hugging Face ecosystem, which is the world's largest ecosystem. So, guys, if you're not familiar with Hugging Face, let me just give you an introduction to Hugging Face. It is the common ground that we all go to for models. How many models are there? Let's see. Models 469,541 models. Tomorrow you'll come, you'll find more models. If you haven't posted a model of your own yet, shame on you. No, sorry. Hmm? I have my models there, but you'll have to. It's not. I'll let you figure out where it is. Right? So anyway, guys, here's the thing. As part of this boot camp, I expect that you guys will post something to GitHub, to Hugging Face, a model of your own. You will fine tune. You'll create a custom model of your own, and you'll post it in your name. You will have your own space here. I do
Asil,
expect you to do that.
also about the an article into Medium, that's one more goal if you
Oh
can see
yes,
for the team.
yes. Thank you for reminding me, Madhu. Guys. And also, each team I expect to write a good, high quality article about your project in Medium, right? And you can only do that if you pick different data sets. Like take something worthwhile. As I said, guys, don't waste your time by picking Wikipedia or some very generic data set. Find some unique data set. As last time I gave you an example, a bunch of Sushinder, Sushinder Rajan, uh, Tamil, and a great fan of the Tamil Dravid culture. He took the Tirukural. Tirukural are to South India what Kabir's Dohas are to North India, right? They are two liners, sayings of wisdom, and he he used that as a basis of this project. He has, by the way, gone to production. It's there deployed. If you are looking at the most popular Kural website, it is his. Oh gosh, you have to ask Sushinder. He must be there in our Discord. Reach out to him. He's done that. He's put quite some effort to do that. Right? So whatever is your favorite literature or medical knowledge or subject of interest or legal or law or whatever it is, go do this projects on that so that you not only learn but you release something useful into the world, some open source that's of actual value into the world. By the way, these are multilingual. So one of the lovely things you can do is if you belong to one of the resource poor languages, right? Then you can take the literature of that language and you could put an English interface, search interface in front of it, right? You could do that. Now, there are all of these models. You have data sets. How many data sets you have to play with? Close to 200,000 data sets, right? So Hugging Face is the largest repository of state-of-the-art models. The only models not here are the commercial models. And at one time, it seemed 2 years ago that the commercial models were the winning horse. Like nobody could compete. OpenAI's GPT 3.5, right, or 4, or big models, right? But the tables are turned now. Frankly, for individual tasks, you can do much better with open source models. Many tasks you can do much better with open source models. In fact, the open source is doing, in a way, beginning to get ahead. Open source models are all hosted here. So that is it. One thing you could do that would help you in Discord, go subscribe to the Hugging Face server, Hugging Face channel. You'll know all the latest news that is happening to Hugging Face. Anyway, coming back to, so this is a world, guys. You're entering a new world. This world has its own sort of palaces and its own markets and its own heroes, and you'll get to know them in due course of time. Yeah. Oh, you don't want to download all these models. Okay. Automatically. Downloads it, yeah. It is it. It's a pull mechanism. Do you notice? Look at the log statements: downloading, downloading, downloading. Right? It's transparent. Imagine, see, guys, those of you who are familiar with object-oriented programming, what is this? This is the constructor. The moment you call the constructor on a model name, the simplicity and elegance of it is it takes care of downloading the weights, model weights, and instantiating the model on your machine. Right? So you get the embeddings. So what does the embedding look like? So suppose I take, it was brillig in the slithy toes, the gyre and gimble in the wave. Let's look at its, oh, I'm sure looking at these numbers, you would say, it's obvious. Right? Yeah. So this is the nature, guys. The paradox is the way machines understand language and the way we understand language is in a very different frame of reference. And yet they understand languages very, very well. These transformers, they're really very good at understanding language. In fact, they are far better at translating from one language to another than we are. So, and we'll do that transformer architecture. So again, for some of you, it's a review. So I apologize for that. See, guys, if I search for a text, a friendship with animals, and you go back and look here, you will not find any text that says friendship with animals. In fact, I doubt the word friendship even exists in this page. Right? So if you were doing keyword search, would you be able to find a search result? You would not be able to find a search result at all. And this is a crucial point. See what happens when I run on this very tiny corpus of 16 documents. You can rest assured that as a startup, you wouldn't succeed if you created a search engine of 16 docs, right? So tiny one. And yet, out of the 16, it has picked the most relevant ones. The first one, it says, the most relevant, it says, is, well, I'll just read out the passage a little bit. It says, golden retrievers are not bred to be guard dogs. And considering the size of their hearts and their irrepressible joy and life, they are less likely to bite than to bark, less likely to bark than to lick a hand in greeting. In spite of their size, they think they are lap dogs. And in spite of being dogs, they think they are also human. And nearly every human they meet is judged to have the potential to be a boon companion who might at any moment cry, "Let's go," and lead them on a great adventure. Do you see the word friendship or animal anywhere in this text? No. But why did the machine pick this? Because clearly the passage itself reflects a deep affection for animals, especially golden retrievers, isn't it? Does it not? You can conclude that whosoever wrote this passage had a great love for golden retrievers. And by the way, golden retrievers are, of course, the best dogs. Anybody disagrees? I have a golden. One of my dogs is a golden. The other is a lab mix. The other result is if you are Lucy, the lab mix belongs to my daughter, and we got a golden 14 years ago. Okay. A golden retriever will come into your life, steal your heart, and change. If you're lucky, a golden retriever will come. Once again, do you see the word animal or friendship anywhere? It doesn't. It conveys an emotion that implicitly implies a friendship with animals. Actually, the last search result has the word, at least the animals in it. Right? And you would have, in normal search, you would have expected it to be number one in the search result, but it isn't. It says if a man aspires towards a righteous life, his first act of abstinence is from injury to animals. This is an Einstein quote. But what is more, and here is where you go beyond what the elastic searches and all of these keyword search engines of the world can do. What if you didn't give it a query? You gave it a picture as input. It turns out transformers can convert a picture into a vector also, a semantic vector also. A picture, a video, and audio. They're fine with all of them. Why? Because they are natural language understanding machines. We express our thoughts, not just in words, but in pictures, in videos, in audio. In fact, we are talking as an audio interface. Right? So suppose I give it a picture. Cute dog, isn't it? And if you know Goldens, you know that this dog is smiling. So you give it and you run the search result. And what does it find in the search results? You give it a picture and it immediately says golden retrievers are little children. Does it seem relevant to this query? Isn't it, guys? It is, right? It's about golden retrievers. And for a love of these furry animals, does this look furry? Can you imagine a machine that has picked on to such nuances of the image? Right? This was happening 4 5 years ago. It was already this revolution had started. A smiling dog. That for that you have to know Goldens. Right? We can go further. You search text with text, query text, then you converted your query into an image. You could do the other way around. You could search with text, but expect results to be from an image database. So one easy image database is it is available um, as again in the open source world. It is the Unsplash. How many of you have used Unsplash? If you haven't, when you use PowerPoint, when you make your presentation slides and you're looking for some images to quickly embed, Unsplash is the website you want to go to because they give you royalty-free images. So you can embellish your presentations with those Unsplash images. If you go to, for example, Adobe Stock or, yeah, that's right. Unsplash is without copyright. Yeah, though as a goodwill gesture, whosoever has taken the photograph, just give $1 or $2 for coffee. They appreciate that, right? Send it. So actually, Unsplash is really a godsend. So this is downloading 25,000 random images from Unsplash, right? So it has everything: houses, trees, birds, lakes, cows, ducks, what you want. Now we are going to search into this database. Let's search for something. By the way, I encourage you to search for something. So clearly, you can tell I love dogs. So my search was, and so I created a little search function. Do you notice that I defined a search function just to take away the drudgery of writing it? So to love a dog. So pay attention to this image, guys. Do you notice that it is not a picture of just a dog? The search engine could have just come up with pictures of dogs, isn't it? What is this picture showing you? You can see to love a dog is an emotion. And does this picture convey the emotion rather than the object? And I hope when you look at this, you realize that the world has changed. You're looking at a revolution in search. Still the same model, right? I don't know how many of you were impressed or are impressed when you see this for the first time, right? It is just amazing. Let's look at the next picture. To love a dog, right? It's not just picking up any dogs. What about this picture? Uh, yeah, sorry, I apologize. For image search, we use clip for a reason. Actually, clip is one thing we will learn in this course. Clip is a multimodal. It can do embeddings. So you have to go from the macro to this. But it's just a question of which model you use. You have to take a multimodal aware model. But you notice that all you do is exactly the same code. You just change the model name. You change the model name to the right model. And to love a dog, okay, so here we go. Look at this and look at this. Yes. Oh, let's see that. Yeah. Yeah, in 20. Yeah, yeah. In fact, 2020 is when they switched over to this completely. Right? See, this paper, Sentence BERT, let's look at that. It came out BERT came out in 2018. By end of 2018, early 2019, Sentence BERT had come out. everybody. It was just a matter of how fast can you take it to production. And you can literally see, that's what I was saying, right around the time the pandemic hit us, you could see a dramatic change in the search results, right? Because everybody has moved to the only people, actually, surprisingly, you see that Googles of the world, they're obviously moving with the pace of research. But the question that you have to ask yourself is, how many of your companies are still using Elasticsearch or Solar or something like that internally? And the next question that you ask yourself is why in 2024 are you doing that? Yeah. You're using it more as a multidimensional analytical database. See, guys, look at this. A machine that can interpret this image and say it's an appropriate response for to love a dog was not possible in 2016. Google couldn't do it, you couldn't do it. Are we getting it? Oh, so nice. Every time I look at that, I smile. So there you go. By the way, you guys have this code. Run it. Please run it on your machines. I want you guys to all run it. Each team, I will come to your room and see what things you're searching it for. Right? So take your rooms. Did you guys acquire a room? This one. Okay, go for it. There are lots of rooms available here. Take your rooms. House near a lake. See, guys, house near a lake is the reason I chose this is it isn't just a thing like a car next to a tree. House near a lake is almost a aspirational dream of most people, right? Everybody imagines that they'll one day have a house next to a lake. It will be so quiet and peaceful, and is their picture of retirement, right, or peaceful living. So, and it tends to pick up images that convey that emotion. So, and by the way, try out your own searches. Jumping dog. If you say jumping dog, it's action. You think it caught on to it? So, and so on and so forth, right? Uh, Path through a forest, it does it, and so on and so forth. I'll let it go. What was the search query here? I forgot. Uh, See, the foundational idea of DALI, diffusion model, will come to it. But it's not. It's a different model. Diffusion is a different model because those are generative. They are not searching. We'll come to it. Hmm. Yeah, right. Lots of benchmarks. Lots of benchmarks. So you look at the results of the benchmark. That is one. And then there are mathematical measures, like, for example, mean average precision, uh, mean reciprocal rank, etc. So when you create your application on documents, we will ask you to report on these measures, on how well your search engine is doing. So the information retrieval world has had these mathematical measures for a long time. No, it's in theory. So what you do is, see, here's how it is. Suppose you have a query and you know which documents must show up in the query as a result. Then what you do is you run it against your machine and see what was the rank of those documents, right? And then you take the mean reciprocal rank. So there are ways to do that, and you learn all of that. See, remember, today has become de facto a review of last time in the first class. That's all right. But now here's the thing. You can use an image to search for other images. So if I use Golden Retriever to search for it, I hope you agree that these look very relevant. They are all in the retriever family. Oh, this one looks like my dog. So there we go. Bit of homework for you. Read this. Two things. We have a coverage of the sentence BERT research paper. I won't do it again. Huh? The recording is there. Please go do it. I want to cover new things now, right? And the sentence transformer. This website, please devour this website. Like, go through every aspect of this website, right? An hour? Yeah, yeah. Yeah, you should include it. Yeah, yeah, of course. Guys, any code that I give you, right, is fair game. Go use it in your projects, in your companies, in your startups. In fact, when I say lots of startups come from here, one of the things is that and we'll give you a lot of code. Uh, we are hoping that that code base is the nucleation point. In the past, they have been. People have run with that code and done their own stuff with it. So by all means, use it. You're free to use it. Even though you'll see a little copyright notice at the top of our source code, I'm giving you the only reason we put it there is to prevent a reverse plagiarism accusation. And I'll